Hello and welcome to E233. I'm your instructor, Gregory Myers. In this video, we're going to take a look at a typedefs example, another in a series of videos that focuses on the typedef enum and typedef structure in the C programming language. And this video is part of a larger series of videos focusing on the fundamentals of the C programming language. And it assumes that you have watched the earlier videos on the typedefs, as well as have a little bit of information regarding how to use things like scanf, fscanf, printf, and fprintf. So this video is going to look at another structure that we are going to see how we can populate using multiple different means. And we're going to break this topic up into two videos. The first video is going to focus a little bit on the setup of this example because it is a little more involved, as well as sort of some of the justification about why you would use a structure as opposed to individual variables. In the second video, then, we're going to focus on how to persistently store the information in a structure, in this case in a CSV file, and then ultimately retrieve it. So to begin with, what we want to do is we want to take a look at the structure, if you would, of this snips file. And so you'll see that it begins with a status enum that contains three different enumerators. The idea here is that I'm going to build a system that's going to track user information, some basic user information like their ID, their first name, their last name, but we would also like to know whether they were active or inactive in our system or potentially unknown status in our system, which leads us to the typedef struct, which allows for us to collect information like the user ID, the first name, the last name, in character vectors, and specifically we're going to treat them as strings. That simply means that out of those 10 characters in the user ID, we can store 9 usable characters, and then the 10th character must be the end of string, or rather the last character must be the end of string. So the longest user ID we could store would be 9 characters long. Likewise with the first name and the last name, the longest usable first name or last name we would have would be 19. Now, we also have the status, which is of status enum type, which allows for us then to once again store whether they are unknown, active, or inactive in the system. A few other things that are different about this example is if you notice that our typedefs _03 accepts input arguments rather than simply void. And particularly, it accepts the same input arguments that your main does. What this does is this allows for us to essentially forward all of the command line arguments to a function. And so we get not only the count of the arguments passed at the command line, but the arguments themselves. So essentially everything that we were doing in main can now be done inside of our typedefs _03. We're actually going to utilize this in two different ways. One is in our get user properties parametric function, which also accepts the argc and argv input arguments, but also in our help. So let's take just a second to see what this means for our help. In this example, we have an additional custom help that is only focused on our typedefs _03. So you can sort of think of this example as being self-contained, but it's elaborate enough that it needs its own help. And particularly what I've done is I've employed a trick here of passing the argc and the argv directly to the help, which then allows for me to utilize those arguments in the output of the help function, particularly if I utilize the %s for the argv square bracket 0. If I rename my executable, it simply gets passed through to the help. So in other words, if I rename my executable from fundamentals _demo to something.exe, then wherever I utilize my argv square bracket 0, you will simply see something.exe, or whatever the name of the executable is. Likewise, if for some reason that first tier switch changes, then that will also get passed through to the help. It's just a way to make your help even more flexible, and we'll see in just a second how that plays out. Now, if you'll notice in the typedefs_o3 function, I've already provided you with a significant amount of code. We will have to do a fair amount of coding in this example, but I went ahead and provided you the structure for our argument triage. And in this case, we're only focused on the switches that come after the ones that ultimately call this function. So in this case, we check to see whether or not we have less than 3 arguments. And if we do, we call the specific help for this example. So in other words, we call our help _typedefs_o3, and we simply pass whatever those arguments were. And that, once again, is an implicit call for help. Basically, it means that the user doesn't know how to use our application. Likewise, we can have an explicit call for help, but unlike the earlier examples in main, which we'll see in just a second, notice here that we're checking argv_2. That means that the user successfully passed the argument that triggered our typedefs demo, but they didn't know what to do beyond that, so they simply provided a /h. And likewise, if they just get themselves into a mess and they don't trigger any of our else ifs, then we simply make an implicit call to help again. Now, to continue with the setup of this, what I've done is I've taken each one of the functions we wish to demo and I've turned them into an additional command line switch by just simply prefixing a / in front of the function name. And so you'll see that we have a getInfo interactive, a getUserProperties interactive, a getUserProperties parametric, and so on. And each one of those were then converted into a switch. And if you notice also, I've given you some examples in this help. So you shouldn't have to work too hard at the triaging of the command line switches to be able to get this example to work. So let's get started. First, what we want to do is we want to go ahead and copy over our typedef enum and our typedef structure and add them to the list that we have already started in our earlier examples, as well as the function prototypes. And then lastly, the function implementations themselves, including any comments. Now, at this point, what we need to do is we just simply need to make sure that our main in our fundamentals driver.c can handle a call to our demo. So in this case, what we want to do is we want to scroll down to the bottom, and where we had our typedefs02, we simply want to check to see if the user has provided typedefs_o3 as a switch, a first tier switch, and we simply want to call our typedefs_o3. But the difference in this example is that we also want to pass the argc and argv that are provided by main. So hopefully at this point, you'll see that what we're doing is we're simply forwarding what was provided to main onto our typedefs_o3 so that we can further process the switches inside this function. And then the last little bit that we want to do is come down here and simply add another line in our help. So for instance, we want to change the switch to 3 and perhaps provide a little better documentation on what it does. But at this point, we should be ready to go ahead and build our project. And let's see here, we've got an error. Let's see what we've got for an error. Oh, okay. So this is a good example right here. We actually cannot have the enum twice with the exact same name. So what we can do here is for the unknown, How about if we just simply change this to unknown status? All right, simple little change there. You always want to be careful to not have duplicate names for any of your enums. And at this point, then you should be able to build it over to your command window. And we can go ahead and run our fundamentals demo.exe, and you'll see that you get your basic help. But then when we provide our type defs _03 switch, you'll get some additional help. And that additional help comes from the triaging that we have in our type defs _03 function. So what we can do is we can go ahead and jump down to that, and let's take a look at how this works. And you'll see that I have duplicated some of my code in main just so that we can see that we are essentially processing the switches a second time. And you'll notice here that if I only pass 2 arguments, I'll make an implicit call for help. And in this case, remember that my arg0 is the name of the executable, and my arg1 is the first tier switch, for a total of 2 switches. Now at this point, we can do minor things like clean up our help. In this case, we've just got to tab this over just a little bit, and we should be set to go. Now, what we'd like to do is jump into why we're doing this example. And the easiest way to understand why we're using structures is to remind ourselves of how we would do this if we did not have structures at our disposal. And to do that, I've set up this get info interactive example. And at this point, all this requires is that we have 3 arguments, with that 3rd argument simply being the get info interactive, and no additional command line information needs to be provided. So to do this, what we need to do is we need to look at the function signature for our get info interactive, and notice that we are provided 3 input arguments, character vectors, which means that they are by reference, which means that we can update them. And we're provided a 4th input argument that is also by reference, or put another way, we have to pass the addresses of each one of these variables so that they can be updated then inside of our function. So to begin with, what we want to do is up here at the beginning of our type defs _03, let's take a second to create some temporary variables. The first name variable, and we're going to go ahead and allocate 20 characters to it. Our last name variable, also 20. And then the user ID, which we'll make 10. And then the last one that we'll need is going to be our status enum. And we're simply going to call it status. And remember right now that none of these have been initialized. They have simply been declared. So at this point, the values that are in them can be thought of as garbage. And the idea here is that we simply want to make a call to our get info interactive, and we want to pass to it each one of our variables. So our user ID, our last name, or rather our first name, then our last name, and then finally the address of our status variable. Now, notice that we did not have to use the ampersand in front of any of the first 3 variables, and that is because they are arrays. We are implicitly passing the address of the first element of that array. So essentially, since they are arrays, then we are already passing them by address or by reference. And this means that we can then update these values inside of our function. And to do that, we simply have pairs of printf statements followed by scanf statements. So in this case, we're going to have a nice prompt that says, please enter a user ID followed by a new line, and then the corresponding scanf with a %s, and then simply the address of the user ID. But once again, remember that these are passed by reference. So effectively what we're doing is we are getting the addresses of these variables. So what we can do here is we'll play around with this and see if we need to actually use the ampersand in this case. So once again, let's see how this plays out. See if this makes sense to you. We can also do the same thing then for please enter a first name followed by a new line, and then scanf %s first name, and hopefully you can start to see the pattern here. But we want to do the same with the last name. And then when we get to the status here, then what we need to do is provide a prompt that says, please enter the status. And I'm going to specify values 0 for unknown, 1 for active, and 2 for inactive. And you're probably wondering where I got that from. Well, you can deduce that from the enum itself by virtue of the order that we have created the enums, or you'll note that at the beginning of my type defs underscore 03, I provided us with a little table that included the description as well as the value for each one of our enums. So you can see that the unknown essentially maps to 0, the active maps to 1, and the inactive maps to 2. And so hopefully you're starting to see some of the advantages of the enums. Well, continuing with this, then what we want to do is we want to figure out how then to store it in our status variable. And remember that once again, the status is being passed by reference. So essentially what I've got is the address of the status variable, and we want to accept it as an integer value. And in this case, we do not, once again, need to provide the ampersand in front of it. And at this point, we might as well go ahead and build it just to see if we've accomplished anything. Now, at this point, we want to go ahead and jump to our display and come back up here to this branch of our else if, and we want to prove that we've actually collected this information and display or print a small table. And so I'm going to start off maybe with a printf, and we can optionally create a border here. And then in between the two, we can simply just print out the user ID followed by a %s and a new line. And in this case, then we can provide the user ID. We can do the same thing now for the first name. As well as the last name. And then the status, which, as we said earlier, is actually going to be a integer, so it's going to be a %d. And there we have our status. Now, let's see if we've accomplished anything. So I'm going to go ahead and build this. And you can, once again, use our help down here as a guide to launching this from the command line. So we know that we have to provide our typedefs underscore 03, but then we also want to provide it with the get info interactive. And at this point then, we should be prompted to enter in a user ID. In this case, I'm going to use my email address, my first name, my last name, and then my status. And I'm going to make myself active. And you'll see that I've got a nice little table here of all of the information that I have collected from the user. Now, all of this was an elaborate example to prove a point. Let's say that in the future, we decided that we needed to collect additional information from the user, perhaps the middle initial or the address or some other information from the user. Every time we wanted to add an additional piece of information about the user, we would have to change our function signature for our get info interactive, and then also change it anywhere else we had called this function. That, you'll discover, is very, very inefficient and also very error prone, which means there's got to be a better way. And that better way is to leverage structures. So once again, let's take a look at our structure. We've already taken a look at our enums. Let's take a closer look at our structure once again. Our structure you can sort of think of as this magic box that contains multiple pieces of information. Think of it as a magic box, a shipping container, tackle box, a craft box, whatever works for you. But the idea is that it essentially allows for you to encapsulate multiple pieces of information, which means that if you go back down to our examples that are focused on the typedef underscore 03, you'll see that every function that accepts a user properties typedef doesn't have to change when one of the fields changes. Rather, the function may have some changes internally, but the function signature does not have to change. So for instance, if you take a look at our get user properties interactive, which is going to be very similar to our get info interactive, if I decide to add the middle initial or the address to my user properties, there will be no changes made to this function signature. And so hopefully you can quickly see why structures are extremely advantageous. So let's go ahead and finish this example. And what we're going to do is we're going to do something very similar to what we had done in our get info interactive, but with the get user properties interactive, instead of having separate variables, what I'm going to do is I'm going to utilize the print statements out of the first example, and then I'm going to store the information directly in the structure. And so this will take just a second for us to get set up. I'm just going to copy the print statements over, and then what we'll do is we'll utilize a similar scanf, but instead of temporary variables, what we'll do, for instance, with the string here that is associated with user ID, we are going to store it directly in the example. Now keep in mind that the example structure is being passed by address. And so what we would want to do then is we would want to say example, and then we would want to point to the user ID. But specifically what we want to do is we want to give the address of the user ID, because remember that the scanf needs to have the address of a variable or the address of a field. Likewise, with the first name, we use the scanf. We pass the %s as the first argument. And then once again, we use the ampersand example. And the first name, likewise for the last name. And then for the status, remember that we switch our data types to %d, but we once again use the address of the example and the status. Now, at this point, what we need to do is we need to have a way to prove that we have successfully updated our structure. And to do that, the easiest thing to do is to jump ahead to our display function. And we're going to use the display user properties multiple times, both in this video and in the next video. But the whole purpose behind this particular example or this particular function is to print out that nice, pretty table in a consistent fashion. So once again, we're going to put a border here. And then in between our borders, we're simply going to print out the fields, starting with the user ID. And somewhere about this point, then we'll provide a %s. But remember now, we're going to be accessing the individual fields in our example variable or in our example structure. So whatever is being passed to the display user properties, we're going to reach in and we're going to display the user ID. We're going to do the same thing now with the first name. Once again, a %s followed by a new line and our example dot first name. And then our example dot last name. And then the last field that we have for this is the status. And once again, that's going to be a %d followed by a new line and example dot status. Now, before we leave this, you want to take just a second to note that we are passing the example by value. So this example structure right here, which means then we can just access the fields using the dot notation. So what I would encourage you to do is look at the several different options that we have already seen just in our typedefs videos so that you can understand how you can access the individual fields depending on whether or not the structure was passed by value or by address. And so this is now a third option that we've seen here to access the individual elements of a structure. In an earlier video, we saw then how, or rather, let me rephrase that. This is how we would access the address of an individual element of a structure. And in an earlier example, we saw how to use string copy then to copy a value into a structure. At this point, then what we want to do is go back up to our typedefs_03, which is going to act like a mini main. And we'll look at our second example here, which once again requires only passing a total of 3 arguments, with the third argument being the getUserProperties interactive, which means that this function will need to have a structure. So what we're going to do now is we're going to create a user properties structure. And we're simply going to call this one example underscore O1. Remember that just like with other variables and arrays, other primitive data types and arrays, whether they're single values or arrays, that this is declared but not initialized. So essentially at this point, all of the fields are garbage. And what we want to do now is we want to call our get user properties interactive, and we want to pass to it the address of our example underscore O1 so that it may be updated inside of that function. Once the function is complete and the example underscore O1 has been updated, we want to then turn around and we want to pass, using the display user properties function, our example underscore O1. This time though, we do not pass the address, but we pass the structure so that we can simply print out the values. And at this point, we should be ready to go with our second example. So I'm going to go ahead and build it. We once again have green. We're going to come over to the command line, and you can either scroll down to your help, or you can simply run this without providing enough switches, and you'll see then how we need to run our second example. So our first switch will be type defs underscore O3, and then we simply borrow this second switch to call the get user properties interactive. And I realize at this point these switches are getting a little bit long, but you'll see that once again we are prompted to provide the user ID, which I will once again enter in my email address, my first name, my last name, and my status. And you'll see that once again, we are in fact getting that nice little table, perhaps shifted ever so slightly from the earlier example. That way you can see that there's no tricks going on here. We are in fact calling a different function. But more importantly, you'll see that I have updated a structure. I have not used 4 individual variables, but rather a single variable that contained a structure. Now, you'll want to see then in our last example how we can do this from the command line. So in other words, we can provide those arguments directly from the command line, pass it to a function and parse it inside of a function, and essentially update a structure. So for this, we're still going to use our example O1 structure, but what we're going to do is we're going to see if we can pass those values directly from the command line. So that if you now count the number of command line arguments you're going to need the executable itself. The first tier switch was our type defs underscore O3, then the switch that calls the parametric version of our get user properties, followed by the 1, 2, 3, 4 pieces of information for a total then of 7 arguments. So if we are provided with an arg count of 7, where the third argument was the get user properties parametric, what we want to do now is we want to make a call to that function, and we want to pass to it the argc and argv that were provided by main to our helper function, as well as the address of our example underscore O1 user properties structure. Now, at this point, what we can do is inside of our get user properties parametric, instead of having a combination of printf and scanf statements, what we want to do now is we want to triage the arguments that come after our get user parametrics, the get user properties parametric switch. So in other words, argv3 argv4, argv5, and argv6. So to do that, what we can do now is we can once again simply use our string copy, and we will leverage our example input argument. For the user ID, then what we want to pass to it or copy to it is going to be our argv square brackets 3. Our first name will be provided from argv square brackets 4. Our last name will be provided from argv square brackets 5. And then for the last field, or the example status, what we need to do is we need to use the a.k.a. function that allows for us to convert our argv square brackets 6 from a character vector or a string into an integer. Now, please note that in all of these examples, I have done no validation. So it's important that you don't blindly assume that the user is in fact providing correct information here. So you would, for instance, want to verify that your argv square bracket 6 actually parses to an integer, or you could have a problem later. At this point, though, we're going to assume for this simple example that this in fact does work. And then what we want to do is come back to the command line, and instead of running the interactive version of our get user properties, what we want to do now is we first want to check to see if our switches triage works correctly. So we'll pass our as the next switch the get user properties parametric, but we won't provide enough arguments, which should result in the help popping up. And the next thing we want to check is what happens if I pass all of the arguments. And at this point, then you'll see that I am passing the correct number of arguments, but I did not actually display anything. So if you come back now to the function, or rather where we called the function in our else if, we can simply reuse our display user properties function that we tested earlier, and we can once again pass to it our example underscore 01. So hopefully at this point, you'll start to see the benefit of writing these functions that allow for us to reuse or encapsulate code. And at this point, you'll see that we have once again printed out our nice little table here, just like in the earlier example where I collected the information interactively. However, this time around, I provided it directly via command line arguments. So that's it for this video. Hopefully you've found this video useful. And once again, please take a second to look at the different ways in which we can access the fields in our structure, and also take a look at our enums. Once again, thank you for watching this video. If you have any questions or comments, don't hesitate to email me.